The first one among them, signal transmission through LTI system. Generally, when we say no signal transmission, then we think that signal to be transmitted, it should be distortionless. Okay, the distortionless transmission should take place when we allow any signal to pass through any LTI system. Okay, for this to happen, two conditions are required to be met for distortionless transmission. The first one is system must attenuate of the frequency components equally. H of omega must be constant. Okay. Second one is phase characteristic to be linear. That means this is the H of omega, and this particular is I of omega is equal to minus omega k. Okay. This is a linear phase and constant magnitude response. These two conditions are required to be met for a distortionless transmission of signal through a system. Now, another one is, what is frequency response? Okay. See, generally a response to something is nothing but whenever input is that particular type of signal, what is the output? Suppose if we say impulse response. When I say impulse response, that means whenever the input to a system is impulse, then what is the output? So that is called an impulse response. Step response, whenever the input to a system is a step, then what is the output? Similarly, frequency response is whenever an input to a system is a sinusoidal function or a complex exponential, then what is the output? Okay, so we will see here important characteristics of this. Generally, in response to any linear time invariant system can be written using convolution. To an arbitrary output arbitrary input signal xn is given by yn equal to summation okay. Now let us give input xn equals to a e to the power j omega t. Okay. Now output yn using the same previous convolution formula I can write it this will become a summation k tending to minus infinity to infinity h of k e to the power minus j omega t. Thus h of omega is summation k tending to minus infinity to infinity h of k e to the power minus j omega k. Now y of n is equal to a times e to the power minus j omega n h of omega. Thus frequency of output signal is equal to frequency of input signal. We have seen that there is no change in the input and output frequency because omega term is a still same omega. There is no subtraction, no addition, no multiplication to this omega. Okay. Only amplitude and phase changes. This amplitude and phase changes due to the characteristics of the system, due to characteristic of the this amplitude change and phase change depends on the system characteristic. Okay. This depends on the system characteristics. So frequency, this is a frequency response which we are telling for any sinusoidal signal or exponential signal. Here we have taken the example of exponential signal. We can take example for sinusoidal signal also. But e to the power j omega n can be written as cos omega n plus j sin omega n. So it is a both cosine and sine added together as a complex exponential and found the result. Okay. So these are the two things which are there to be explained in linear time systems and signals. We will see few problems understanding the frequency response of the system. Suppose a system is defined by h of t for which h of omega is 1 upon 2 plus j omega. If input to this system is sine 2t and output is yt, then yt is question mark. We have to find the yt. Now, since we know the yt frequency will remain same as 2t, but the phase in the input is 0 and the amplitude at the input is 1, but amplitude at the yt will be different. We will see how it will be different. Omega is equal to 2. Thus, h of omega at omega equal to 2 is equal to 1 upon 2 plus j2. Thus h of omega equal to 2, magnitude is how much? 1 upon 2 root 2. Phase of h of omega is minus tan inverse 2 upon 2 equals to minus pi by 4. Thus yt is equal to mod of h of omega equal to 2 sine 2t minus angle of h of omega. Okay, so this will be 1 by 2 root 2 sine 2t minus pi by 4. Actually it is not plus, it is plus. So angle of phase of h of omega is nothing but minus pi by 4. So this is my yt. Frequency is same, but amplitude and phase, they are different. Okay. Again another problem. Difference equation presentation of a system is given. Yn minus 1 by 2 y of n minus 1 equal to 2xn. Y of minus 1 is equal to 3. For this, find natural response. Now what is this natural response? See, the natural response of this system is when input is 0, then whatever the behavior of the system is, that is a natural response. Then we can find natural response. So input is 0, that means xn equal to 0. That means yn can be written as 1 by 2 y of n minus 1 equal to 0. Okay, now it's a very easy to solve now. From this, yn is equal to k times of 1 by 2 to the power n. Okay, and greater than equal to 0. Y of minus 1 is equal to 3. So y of for n equal to minus 1, y of n equal to 3. Substituting this in the given equation, 3 is equals to k times of 1 by 2 to the power minus 1. This gives value of k as 3 by 2. Thus yn equal to 3 by 2 1 by 2 to the power n, or 3 dot 1 by 2 to the power n minus 1. Okay, this is the natural response for the given system. So the important thing to remember is, if natural system is asked in the question, that means input is 0. Okay, putting input as 0, solve the differential equation either using Z transform or discrete time Fourier transform, anything we can use. Okay, Z transform is the easiest thing to use. Okay. This is also equal to finding the complementary function of the differential equation. Okay, in differential equation, finding the complementary function, we are using the operator D and solving the auxiliary equation and getting the roots. On getting the roots, I am just writing. So what are the type of roots? I am writing the equation of yt or yn. Another problem based on the convolution. If I have signal xn with duration minus 4 less than equal to n less than equal to 4, and system impulse response xn with duration minus 5 less than n 7, then the range of yn, which is convolution of xn with hn, is solution. Simple. Sum of the lower limit sum of upper limit. Okay, this is the range for yn. So this will become minus 4 plus minus 5 less than equal to n less than equal to 4 plus 7. This will become minus 9 and less than equal to 11. So this is the range for yn. Okay. Write the equation of the given waveform in terms of step function. Given waveform Wt is equal to one, 2, 3. 1, 2, 3 and 4. Okay. For this we have to write, I should say, express Wt in terms of Ut. Solution. See, the waveform is starting from t equal to 1. Okay. So Wt can be written as initially u of t minus 1. Okay. At t equal to 2, amplitude has become 2. So I have to add one more step function at t equal to 2. At t equal to 3, again amplitude has increased by 1. So it will become u of t minus 3. Okay. And this process continues. At t equal to 4, amplitude is suddenly dropped to 0. Okay. So this is already 3 addition. I have to subtract 3 from this. So I have to write 3 times u of t minus 4. This is a representation of the above Wt in terms of Ut. Just see it once again. This waveform is starting from t equal to 1. So u of t minus 1 is the proper way of starting this. Okay. From u t minus 1, again at t equal to 2, again 1 is added to this. So it will become u of t minus 1 plus u of t minus 2. Again at t equal to 3, again 1 more is added. So u of t minus 1 plus u of t minus 2 plus u of t minus 3 becomes 3 times. Okay, so 3 is the amplitude we are getting at t equal to 3. At t equal to 4, amplitude is suddenly getting down to 0. That means 3 is getting subtracted from this waveform. So subtracting 3 at t equal to 4, we just have to write minus 3 u of t minus 4. Okay. One more problem. Waveform xt is given as minus 5, 2 plus 5. This is minus 4. This is plus 4. Amplitude is 1. Now, for what value of t thus x of 10t minus 5 will be 0. Okay. In the given waveform, xt is becoming 0 for t value greater than equal to 5, t value less than equal to minus 5. Thus, 10t minus 5 greater than equal to 5 will give the value of t greater than equal to 1, it is 0. And 10t minus 5 lesser than equal to minus 5 will give t value less than equal to 0. Thus, for these values of t, the waveform will be, the value of x of 10t minus 5 will be 0. Okay. So, need not to draw the graph and see. Directly by substituting 10t minus 5 equal to those values of t for which original xt is becoming 0, we can find the value of t. Okay. So, these are the few problems which we have solved in this unit. Okay. We will see other problems related to frequency domain analysis in the